Hello. The following is the first example in Chapter 2. We wanted to decide whether each relation defines a function. Remember, a function is any relation where your independent variable corresponds to exactly one dependent variable. That's a bunch of words basically to say the x's don't repeat. One thing to keep in mind, relations are simply a set of coordinates. That's what f, g, and h here are representing. So f is the set of coordinates 1, 2, negative 2, 4, and 3, 4. So what I want to do is I want to figure out, are these functions? This is one big relation, so I'm going to look at the x's. 1 corresponds to 2, negative 2 corresponds to 4, 3 corresponds to 4. 1, negative 2, and 3 do not repeat. That means that f is a function. Therefore, for f, yes, it is a function. So let's look at g. G, if we look at the relation, it's the set of all coordinates 1, 1, 1, 2, 1, 3, and 2, 3. I'm going to look at the x coordinates. Now, 1 corresponds to 1, 1 corresponds to 2, 1 corresponds to 3, and 2 corresponds to 3. I look at this and ask myself, do any of the x's repeat themselves? And the answer here is yes, they do. The 1's are repeating here. So because of that, g is not a function. Now let's look at h. With h, we have the set of coordinates negative 4, 1, negative 2, 1, negative 2, 0. Let's look at the x's. Negative 4, negative 2, negative 2. If you look, notice that negative 4, negative 2, and negative 2, well, only 2 of them repeat, unlike over here where 3 of them repeat. But that doesn't matter. If any of the x's repeat themselves, this is not a function. Therefore, h, the answer is no, it is not a function. Now, I also want to talk about domains and ranges. Domain is simply the set of all of your x values. So if I look at f here, I want to look at all my x values. 1, negative 2, negative 3. Well, I want to write them all down here because all of them need to be accounted for. But I want to try and do it in numerical order. Therefore, I should put negative 2 first, followed by 1, followed by 3. If any of these repeated like they do over here on G, you only need to write them once. In other words, there's no reason to write 1, 1, 1, 2. Instead, I'm just going to write 1, 2. Let's look at H. The domain for H, all the x values, negative 4, negative 2, negative 2. Now notice the negative 2 repeats itself, so you should only write it once. So your domain here is negative 4, negative 2. I also want to talk about range now. Range is a lot like domain, but instead of being the set of all x coordinates, it's the set of all y coordinates. And again, we just denote range with an R. So I'm just going to underline the y values here. I have 2, 4, and 4, and much like the domain, you only write it down once. So I'm going to have the set 2, 4. Look at G. Here's a y, here's a y, here's a y, here's a y. So the y values are 1, 2, 3, and 3. Just remember, don't repeat the y's when you write down the range. So you have 1, 2, 3. Now look at H. 1, 1, 0. So again, the range in this case will be 0, 1.